Hello and welcome to the Futurist 3D video training series. My name is Jeff Christiana and this is a video number 30 of the Skeinforge 47 video training series on how to use temperature. Under Skeinforge, your temperature tab, used by default, we have in our profiles, we have activate temperature. If you did not activate this temperature, it would use the default setting in your start.g code. So we're going to go to our replicator G folder, our Skein Engines folder, Skeinforge 47, Skeinforge applications, our preferences, and then here are all of my TF3D profiles. I'm going to go into a 12x12. We're going to go into the profiles, we're going to go into alterations, and then start. So this is your start.g code. Very simple, straightforward. In the start.g code, you'll see an M104, which sets the extruder temperature, and the M40, which sets the bed temperature. There's nowhere in Skeinforge where you can set the bed temperature. This is the only place. And if you have an LCD readout, you can set your temperature in there. But this is where you'd want to set this. And for ABS, it should be set to 110, for PLA 70. So the default, well not default, but the setting that gets applied in your start.g code is going to be 225 Celsius. So if you check the checkbox in replicator G, this will still work. This is going to get your head up to temperature. This is going to get you your primed extrude. It's going to extrude some plastic, and then it's going to start and go into the print job. So this will always be used for the very first setup, and then once it finally moves into your print job, we'll close all this, it's going to use this temperature if this is checked. So let's run down the list here. So your rate, this is your rate of cooling and rate of heating. So this rate of cooling will, basically the default is 3, and this is how fast the head will cool in degrees of Celsius per second. So it'll go down 3 Celsius a second. It's kind of just to kind of control the tip from cooling down too fast. So I guess if you wanted to keep your tip hotter longer, you could increase this number, and then so when you're ready for the next print job, you don't have to wait as long. So we'll do a kind of a gradual step down. I've always left it at 3. The heating rate, 10 Celsius a second. I've never really made this a larger or shorter number. I've been happy. Really, it depends on how much your heat resistor or your heat canister in your tip heats up, and how much power you deliver to it. But this can control, if you got a tip that'll go hot in 1 minute and your bed can't catch up, then you're going to want to make this a higher number so you can slow that tip down to where your bed your bed temperature and your tip temperature get to the same temperature and they can print at the same time. So your temperature, your base temperature is the base of your object, 225 Celsius. For this profile, this is what I have set. This changes for others. So I want to keep the base hot. I want it to adhere to the bed. I want it to be a nice, smooth, even nice flowing plastic. I don't really care if it's too hot or not on that first layer. Now the next layers, you want to lower the temperature in some cases. Sometimes you don't need to, sometimes you will. It depends on really what object you're printing. So if you're going to print for, say, a wine stem, the base can be hot, but you want the next couple layers. So the object first layer, infill, and this sets your infill, and you can also have different parameter. And I keep them the same because the time you go from infill to the parameter, you don't want it orbiting, and spitting out plastic all over the place. So I keep these the same. And then the next layer, temperatures, for this is your first layer, and then your next layer is for the rest of your object. This particular one, I keep all of them 220. So let's say you're doing a wine stem, you want to stay hot, and then you want to start lowering in temperature so you don't have your plastic melting. You'll see that. It depends on the plastic that you use. Every type of plastic uses a different properties. So your black to your white to your clear. Your clear and your natural melt at the lowest temperatures. If you're using color, it's going to melt at 10 to 20 degrees Celsius higher. And if you're using ABS, this all changes. ABS, these are going to want to be 240, 250. ABS holds its form better when extruded than PLA. PLA melts at a much lower temperature and has a much more susceptibility of drooping, especially when you're doing bridging. Now your support layers, I've been playing with this. Now, it's recommended that your support layers are a different temperature than your regular job, but the problem with that is that when you're printing your object, your head will print, let's say, so you're going to print your support layers. You're printing your support layers, and let's say you've got a column. We're looking at this sideways, so this is your object. So you print your support layers, and then your object is actually in here. Then you got more support layers, and then your object actually goes out like this. So you're printing out a T, and you want support here, and of course it's going to print a raft underneath it. So you've got that support. So what happens is when it's doing this layer right here, it's going to print support material, and then if you got a different temperature, it's going to sit here and orbit until it hits that temperature. So you could be spitting out plastic, and then when it starts to print it, it's such a small area that you don't get a good layer. You get just a spotty layer. So keeping these the same, it's going to print that support material, it's going to print your object, it's going to print the support material, and it's not going to sit there in orbit. Now, there's probably a reason for doing this, but it just doesn't work. From what I have found, it also wastes a lot of time. And I've had no problem breaking away the support structure for something like this. So, and on the front of the website, you'll see I've got a fan bracket that this is the temperature settings that I used for, you know, the support material and the actual object. So this has been temperature for Skeinforge 47, and we will see you in the next video.